Welcome you all for the discussion of probability. So in this video, we are going to discuss about some concepts of probability. First, we shall start with the definition of a random variable. So as the name itself suggests, it is a variable that takes a random values. So if we look into the definition of random variable, it says random variable is a real value that is assigned to outcome of an experiment. Suppose we are conducting some experiment, then there are possible outcomes. So there are various outcomes. We can associate a real number to each of the outcome. Then the set of all such outcomes, the values that is assigned to such outcomes is called a random variable. To understand this, let us take a simple example. Suppose the experiment we are conducting is the toss of a coin. We are just tossing a coin, say, assume. So, treating this as an experiment, now there are two fair possibilities. There are two outcomes. One is either we may get head or we may get tail, excluding some accidental cases. Sometimes it may stand, means it may not be head or tail. Excluding such cases, two fair outcomes are head or tail. So you can assign 1 to head, then 0 to tail, or in either way you can assign 0 to head, 1 to tail. Anyway, you can assign any real number to these possible outcomes. Then these real numbers 1 and 0 are called random variables. Mathematically, we may define random variable as a function that assigns real numbers to each outcome of an experiment. So this is about the definition of random variable. Then if we consider any random variable, there are two possibilities to assign values to it. Suppose we have a random variable, then either it can take finitely many values. If it takes finite values, or we use one more word, that is strictly mathematical word, discrete values, then we say that, see, random variable that takes discrete values is called discrete random variable. If the random variable takes infinite, for example, it may take infinite, or strictly speaking uncountably infinite. So just treat it as an infinite number, uncountably infinite. If the random variable takes values like this, then it is called continuous random variable. So any random variable, depending on the nature of its values, it is divided into two classes. One is discrete random variable and another one is continuous random variable. Then we define probability function. This is the first point. Second point. Third point is probability function. A mathematical function p of x is called a probability function. It is called a probability function if it satisfies two conditions. One is it should be greater than or equal to 0 always. Possibility of occurrence of x should be greater than or equal to 0 always. It should not be negative. So this is we can call as non-negative. Then the second condition is if you add all the possibilities, if you add all the values of p of x, then that sum should be equal to 1. Then the set of all values of input x and probability function p of x, this is called probability distribution. This is called probability distribution. So probability function is a mathematical function satisfying two conditions. One is each value of the function should be non-negative, and the second condition is the sum of all possibilities should be equal to 1. If p of x is a probability function, then the collection of all values of x and p of x, this set is called a probability distribution. Okay. If x is a random variable, discrete random variable, then this distribution is called discrete probability distribution. If x is a continuous random variable, then it is called continuous probability distribution. So the classification of probability distribution depends on x, the input value. Okay, this is about random variable, discrete and continuous random variable, and probability function. So next we have one more important definition: how to compute mean, standard deviation, and variance of the given distribution for these random variables. Okay, so we have mean. So usually we will be given with the distribution like this. The distribution like this. That means x and p of x value will be given. Then the mean, which is denoted by mu, can be computed using the formula summation x into p of x. You have to take the product of corresponding values of x and p of x, then take the summation. Then variance. Variance is given by, after computing mean, you have to take, yes, variance is denoted by b, then take the difference x minus mu whole square into p of x. This will give you the variance, and this summation runs over all values of x. And the standard deviation, which is denoted by sigma, is given by square root of the variance. So these are the some important formula related to random variables and probability function. So these are the required inputs to solve problems on random variables. So here first we'll consider problems of simple type. Let us consider first problem. Problem number 1. Show that the following distribution represents a discrete probability distribution. Show that the following distribution, I don't write it completely, I'll just write few words. Distribution represents discrete probability distribution, and find mean and variance. The given distribution is x and p of x. Values of x are 10, 20, 30 and 40. And values of p of x are 1 by 8, 3 by 8, again 3 by 8, 1 by 8. Okay, solution. First, let us analyze the given problem. See here, the distribution is given, probability distribution is given, and we have to show that this distribution actually represents discrete probability distribution. We have to show that this distribution is a discrete probability distribution. Anyway, it's a distribution, no doubt in that. We have to show that it is a probability distribution. That means we have to show that this p of x is a probability function. It is enough if we show that p of x is a probability function. So if you look into values of p of x, it can take values 1 by 8, 3 by 8, 3 by 8, 1 by 8. So clearly p of x is greater than or equal to 0. So first condition is clear. And the second is summation p of x. I have to add all the values of probability function. 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. This summation is clearly equals to 1. So p of x is a probability function. P of x is a probability function. And so the distribution is discrete probability distribution. So this proves the first step. Second is we have to compute mu and b, right? To compute mu, number 1, mu, that is mean. The formula is summation x into p of x. You have to take the product of corresponding values of x and p of x, then the summation over all the values of x. Now 10 into 1 by 8, that is 10 by 8, plus 20 into 3 by 8, it is actually 60 by 8, plus 30 into 3 by 8, so it is 90 by 8, plus 40 into 1 by 8, 40 by 8. You can check that this will be 90 plus 10, 100, 60 plus 40, 100. So 200 divided by 8, so it is 25. Next, I have to compute variance. Variance is given by V. V equal to the formula summation x minus mu whole square into P of x. That means from each value of x, you have to subtract 25, that is mu, then square, then take the product with P of x, finally take the summation. So it will be actually 10 minus 25 whole square into 1 by 8 plus 20 minus 25 whole square into 3 by 8 plus 30 minus 25 whole square into 3 by 8 plus 40 minus 25 whole square into 1 by 8. You can check that it will be 75. So this completes the solution of the first problem. Okay. Now let us consider one more problem. Problem number 2. Find the value of k. Find k such that the given distribution is discrete probability distribution. So it is just they have given is here instead of discrete they have used the word finite. Finite, that is same as discrete. Finite probability distribution. Hence find mean and standard deviation. Mean and standard deviation. Also find find p of x less than or equal to 1, p of x greater than 1, and p of minus 1 less than x less than or equal to 2. Okay, solution. Oh yes, sorry. Distribution is not written. I had to write down the distribution. The given distribution is here the values of x and the values of p of x. Values of x runs from minus 3 to plus 3. And the corresponding functional values k, 2k, 3k, 4k, 3k, 2k, and k. Now solution. So the solution of this problem involves 3 steps. In the first step, we need to determine k, assuming that the given distribution is a finite probability distribution. Second step, we need to determine mean and standard deviation. Last step, we need to find the possibility of x less than or equal to 1, then possibility of x greater than 1, finally possibility of x lying between minus 1 and 2, including 2. Okay, let us discuss about the first part of the solution. We have to consider this as a probability distribution and assuming that we need to find the value of k. Since the given distribution is a discrete probability for finite probability distribution, we must have see each value of p of x should be greater than or equal to 0. Obviously k greater than or equal to 0, first condition, and summation of p of x equal to 1. So that is summation of p of x means k plus 2k plus 2k. Let us write it in order. K plus 2k plus 3k plus 4k plus 3k plus 2k plus k equal to 1. So that implies if you had this 4 plus 6, 10 plus 4, 14 plus 2, 16k equal to 1. So k equal to 1 by 16. So k is 1 by 16. So that completes the solution of first part. Second part, we have to compute mean. To compute mean, mu. What is the formula? Summation x into p of x. Okay. What is x into p of x? Minus 3k minus 2k, again minus 3k, plus 0 into k, plus 1 into 3k, so 3k, plus 2 into 2k, that is 4k. I hope this was a mistake. It should be minus 4k. So plus 4k plus 3k. You can check that minus 3k plus 3k get cancelled, minus 4k plus 4k, minus 3k plus 3k, 0. So mu is 0. Next, variance. We need actually to compute standard deviation. For that, we have to compute variance first. Variance V equal to summation x minus mu whole square into p of x. This is the actual formula. But mu is 0, so it is summation x square p of x. That is minus 3 whole square into k. So it is 9k plus 4k. Okay, it is actually 8k, 2 square 4 into 2k. So 8k plus 1 square into 3k, 3k plus 0 plus 3k plus 8k plus 9k. Adding all this, we get 9 plus 9, 18, 18 plus 8 plus 8, 16, 34 plus 6, 40 by k. Oh, sorry, 40k it is. 40k, but k is 1 by 16, so 40 divided by 16, it is 5 by 2. So standard deviation is, it is actually 2.5. So standard deviation is, that is sigma equal to square root of 2.5, it is approximately 1.58. So that completes standard deviation. Yes. And then finally we need to compute, let us write the distribution again because it is unseen. I can write the distribution again. Finally we have for minus 3, it is k means 1 by 16, minus 2, 2 by 16, minus 1, 3 by 16, 0, 4 by 16, 3, okay, sorry, that is plus 1, 3 by 16, plus 2, 2 by 16, plus 3, 1 by 16. Okay. Now we need to compute three parameters. So the first one is we have to compute p of x less than or equal to 1. That means possibility of x being less than or equal to 1 is, say this is the possibility of x equal to 1. Less than or equal to 1 means you have to take the all values of the list including 1. All values less than or equal to 1. So it is actually p of minus 3 because here x starts from minus 3, plus p of minus 2 plus p of minus 1 plus p of 0 plus p of 1. That is, I have to add all these values. So since common denominator have 1 plus 2 plus 3, 6 plus 4, 10 plus 3, 13. So you can check that it will be 13 by 16. Next, p of x being greater than 1. P of x greater than 1 means you had to take values of p of x to the right of x equal to 1, excluding x equal to 1. So it is actually p of 2 plus p of 3. So it will be 3 by 16. Next, point number 3. Now we need to compute p of minus 1 less than x less than or equal to 2. That means possibility of x lying between minus 1 and 2. So it is actually, you can check that it will be from p of 0 to p of 2, right? So it is p of 0 plus p of 1 plus p of 2. So it is p of 0 4 by 16 plus 3 by 16 plus 2 by 16. Common denominator, just add numerators. 4 plus 3, 7 plus 2, 9 by 16. So that completes the solution of problem number 2. Let us consider one more problem of the same kind. Let us write the statement of the problem. Problem number 3. Find the probability distribution of a variable x. Find the probability distribution given by the following table. Okay, sorry. Find k such that the probability distribution is given by the following table. So again, here we need to compute the value of k, and we have to compute also compute p of x greater than or equal to 5, p of x greater than or equal to 5, and p of x 3 less than x less than or equal to 6. Solution. Here, okay, statement is not yet complete because the distribution is not given right. So x, values of x are 0, 1, 2, 3, 4, 5, 6, and corresponding probability function is given by k, 3k, 5k, 7k, 9k, 13k, 11k it is, sorry, 11k, 13k. Now, the probability distribution is given. From this, assuming this, we need to find the value of k. So clearly, we must have, since it is a probability distribution, we must have p of x is a probability function. That should be a probability function. So p of x is a probability function means it has to satisfy two conditions for a probability function. That is p of x greater than or equal to 0 and summation p of x equal to 1. It has to satisfy these two conditions. So the first condition implies that k must be greater than or equal to 0, because each value of p of x should be greater than or equal to 0 means k must be greater than or equal to 0. And summation p of x, that is k plus 3k plus 5k plus 7k plus 9k plus 11k plus 13k equal to 1. 20, 20, 40, 48 plus 1. So you get 49k equal to 1, or from that k equal to 1 by 49. So that completes the value of, first step, determining the value of k. Next, apart from that, we need to find p of x greater than or equal to 5. Now, p of x greater than or equal to 5 is equal to, actually I have to consider all the values x greater than or equal to 5, including 5. So it is actually p of 5 plus p of 6. So that is 11k plus 23k is 40, 24k. So that is 24 by 49. And next, p of 3 less than x less than or equal to 6. That is excluding 3. That means p of 4 plus p of 5 plus p of 6. So it is already P of 5 plus P of 6 we have taken, that is 24k plus 9k, 33k, that is 33 by 49. So this completes the solution of the second problem. So let us discuss one more problem. Finally, let it be the last problem. So the statement of the problem is problem number 4. A random variable x has the following probability function for various values of x. So given the probability distribution, actually it is just a distribution, that is values of x and values of p of x. Values of x are 0 up to 7, 1, 2, 3, 4, 5, 6, 7. And the values of p of x are 0, k, 2k, 2k, 3k, k square, 2k square, finally 7k square plus k. Now we have to determine k. Point number 1, find k. Point number 2, evaluate p of x less than 6. Point number 3, evaluate x greater than or equal to 6. And last point, evaluate possibility of having x strictly greater than 3 and less than or equal to 6. And finally, also mentioned, also find the probability distribution. So if the distribution is given, we have to assume that as a probability distribution and then determine the value of k, then determine p of x less than 6, p of x greater than or equal to 6, and p of x lying between 3 and 6, then find the probability distribution. That means for finding the probability distribution, it is enough if you rewrite this table by substituting the value of k. That is enough. There is nothing to do with that. Okay, solution. So to find the probability distribution, we must assume p of x greater than or equal to, p of x is a probability function, so it should be greater than or equal to 0. Assume p of x a probability function, that is, it has to satisfy two conditions. First one is p of x greater than or equal to 0, and the second one, summation p of x equal to 1. So p of x greater than or equal to 0 implies k greater than or equal to 0. So k greater than or equal to 0 and summation p of x, that means k plus k plus 3k plus 2k plus 2k. So 5k, k, 3k, 5k, 8k plus 9k, 9k plus k square plus 2k square plus 7k square, 10k square equal to 1. So that is, if we write this in order, 10k square plus 9k, 9k you can write as 10k minus k minus 1 equal to 0. I have just shifted this 1 to the left hand side. So you are taking 10k as a common factor, you get k plus 1. You are taking minus 1 as a common term, you will get k plus 1 equal to 0. So that implies k will be either equal to minus 1 or 10k minus 1 equal to 0 or k equal to 0 0.1 or 1 by 10 you can write, or k equal to 1 by 10. Clearly this value we cannot consider, that should be excluded because we must have k greater than or equal to 0. So this is not included. So there is the only possibility of k is k should be 0 0.1. So k is 0.1. Now the probability distribution is x, here p of x, 0, 1, 2, 3, 4, 5, 6, 7. So 0, 0.1, 0.2, 0.2, here 0.3. So k square you get. So k square means 0.1 whole square. 2 into 0.1 whole square. So it is 7k square plus k. 7 into 0.01 plus 0.1. So it is 1.07. Now you can check these values as the calculation is easy. You can check this later. P of x less than 6, that is I had to add all these values. 0.1 plus 0.2 plus 0.2, this is 0.5 plus 0.3, 0.8 plus 0.01. It will be 0.81. P of x greater than or equal to 6 will be, that means I have to add only these two values, x greater than or equal to 6. So 0.02 plus 1.07. You can check this should be, you can check this, it will be 0.19. Yes. P of x greater than or equal to 6, right? So it is, sorry, it is not 1.07, it is 0.07. Okay, 0.17 it is, sorry. 0.17 it is. So 0.02 plus 0.17, 0.19, correct. So finally, there is one more value, that is P of 3 less than x less than or equal to 6. So I have to add these values. You can check that this will be 0.33. So this is how we can discuss problems on finding the value of k and problems on finding mean and standard deviation, and also the probability of x lying between two particular values. So this will be of problems on random variables. In the next videos, we will discuss problems on discrete probability distribution. Under that, we will have two concepts. Let me discuss that in the next video. Thank you.